The Tunguska Incident. The Tunguska Incident occurred on June 30, 1908, near the stony Tunguska River in Siberia, Russia. This date and place are etched in world history due to the magnitude and impact of the event, and have been the subject of extensive research in the scientific world. This region of Siberia is known for its vast forested areas and low population density. The area where the explosion occurred was inhabited and occasionally hunted by the local Evenk people. At the time of the incident, a huge fireball appeared in the sky, followed by the sound of an enormous explosion. The explosion affected an area of about 2,150 square kilometers and briefly paralyzed all life in the area. According to witness accounts, the explosion took place in the morning, and the fireball in the sky eclipsed even the sun with its brightness. The epicenter of the explosion was in the upper layers of the atmosphere, about 5 to 10 kilometers above the ground. This strengthens the theory of an air explosion caused by a large meteorite or comet breaking up in the atmosphere. As a result of the explosion, about 80 million trees were toppled, and from the center of the explosion, trees were knocked down in a circular pattern. The shock wave of the explosion was felt even in settlements about 1,000 kilometers away. Tremors from the impact of the explosion were recorded even in Moscow. Nevertheless, the sparsely populated nature of this area greatly reduced the possible loss of life. The location of the Tunguska event presents difficulties for research due to its geographical and climatic characteristics. The explosion site is surrounded by swamps and is difficult to access for most of the year. This made it difficult for scientists to conduct in-depth investigations following the explosion. The first scientific expedition was carried out by a Soviet research team led by Leonid Kulik in 1927, 19 years after the event. Kulik looked for a large crater at the site of the explosion, but did not find one, which strengthened the theory that the explosion took place in the atmosphere. The location and nature of the explosion kept researchers busy for years, and many scientific theories were put forward. The epicenter of the event is located at the coordinates 60.8853 degrees north latitude and 101.89440 degrees east longitude. This region has been the center of many scientific discoveries and research over the years. Thanks to modern technology and space observations, more has been learned about the possible cause of the explosion, and measures have been taken to prevent such events from happening again. In the following parts of this documentary, we will discuss the scientific theories of the Tunguska incident, eyewitness accounts, and the results of modern research. We will learn more in depth about the causes, consequences, and impact on humanity. Scientific theories of the Tunguska event. Many scientific theories have been proposed over the years to solve the mystery behind the Tunguska event. These theories offer various hypotheses to explain the cause and nature of the explosion. Here are some of the scientific theories of the Tunguska event. 1. Meteor theory. The most widely accepted theory is that the Tunguska event occurred when a large meteoroid entered the Earth's atmosphere and exploded. According to this theory, the meteoroid overheated while traveling at great speed through the atmosphere and exploded due to high pressure. The fact that the explosion did not leave a crater at ground level supports this theory. The shock waves and destruction caused by the explosion are consistent with the results of an air explosion of this magnitude. 2. Comet theory. Another popular theory is that a comet entered the Earth's atmosphere and exploded. Comets are usually composed of ice and dust and are less dense than meteoroids. This theory explains the absence of a crater at ground level after the explosion and the absence of radioactive traces. It is also possible that the vaporized components of the comet created a large explosion in the atmosphere. 3. Antimatter theory. A more speculative theory is that the Tunguska event was caused by an antimatter particle hitting the Earth's atmosphere. When antimatter comes into contact with matter, it creates a sudden and massive burst of energy. However, there is not enough evidence for this theory and it is not widely accepted today. Nevertheless, due to the mystery and unique nature of the event, such speculative theories come up from time to time. 4. Natural gas explosion. Theory. Some scientists have suggested that the Tunguska event was caused by the explosion of methane gas accumulated underground. The vast permafrost regions beneath Siberia contain large amounts of methane gas. According to this theory, the methane gas seeped to the surface and somehow ignited, causing a massive explosion. However, this theory has not been widely accepted because the effects and shape of the explosion are different from what would be expected from such an explosion. 5. Alien theories. Due to the nature of the Tunguska incident, various alien and UFO theories have also been put forward. According to these theories, the explosion was the result of the detonation of a spaceship or alien technology. However, such theories lack scientific evidence and are generally considered conspiracy theories. 6. Theory of electromagnetic phenomena. Some researchers have suggested that the Tunguska event may have been caused by a large electromagnetic event. This theory suggests that such an explosion could have occurred as a result of a large energy discharge in the atmosphere or the effects of a solar flare. However, there is not enough data to support this theory. 7. Large ice particle theory. Another interesting theory is that the explosion occurred when a large piece of ice hit the Earth. According to this theory, a piece of ice that broke off from a large comet entered the Earth's atmosphere and created a huge explosion. Although the ice particle theory seems plausible in terms of the absence of craters after the explosion and the absence of traces at the site of the explosion, it has not been widely accepted. Conclusion. Scientific theories of the Tunguska event present various hypotheses that attempt to explain the nature and cause of the event. The most widely accepted theories center on a large meteoroid or comet exploding in the atmosphere. However, no definitive conclusion has been reached as to what exactly happened. In the following parts of this documentary, we will explore these theories in more detail in the light of eyewitness accounts and modern research. The Tunguska event remains a mystery in the scientific world that is still waiting to be solved. Eyewitness testimonies. Witnesses to the Tunguska incident have given many testimonies describing the impact and severity of the explosion. These eyewitness accounts provide important clues about the nature and effects of the event. Here are the detailed testimonies of some eyewitnesses. 1. Semyonov. Narrative of the Elders. Vasily Semyonov is a peasant who witnessed the Tunguska incident and lived in the immediate vicinity of the explosion. According to Semyonov's testimony, in the morning, he saw a bright light in the sky and then heard a huge explosion. The explosion was so powerful that Semyonov found himself thrown to the ground. The windows in his house shattered, and a heat wave was felt. Semyonov testified that he was knocked down by the shock wave of the explosion, and mud was poured over his head. This testimony reveals the sudden and devastating effects of the explosion. 2. Chuchan. Narrative of an Evenk hunter. Chuchan was a hunter from the Evenk people and was located near the area where the incident took place. According to Chuchan's testimony, a huge fireball appeared in the morning sky. The fireball was bright enough to drown out the daylight and was followed by the sound of a huge explosion. Chuchan said that after the explosion, a huge wind blew and trees in the forest toppled over. This testimony is important for describing the direct visual and physical effects of the explosion. 3. Nikolaev. Childhood memories. Semyon. Nikolaev, a resident of Petrograd, St. Petersburg, was a child at the time of the incident. Nikolaev remembers being at home on the day of the explosion and hearing a huge explosion in the sky. He described the sound as a succession of thunder. According to Nikolaev's testimony, as a result of the explosion, all the windows in the house were broken and he felt a great tremor. This testimony shows that the effects of the explosion were felt even at great distances. 4. Kezhemskaya village witnesses. Many residents of the village of Kezhemskaya witnessed the Tunguska event. According to the villagers, they saw a great brightness in the sky, followed by the sound of a powerful explosion. Villagers reported that a great wind blew after the explosion and trees were uprooted. In addition, the heat wave from the explosion caused fires in the village. Testimonies from the village of Kezhemskaya illustrate the direct impact of the explosion on the local population. 5th Evank Chief, Alexei Kulev. Alexei Kulev was a chief of the Evank people and was several kilometers away from the scene at the time of the explosion. According to Kulev's testimony, he saw a huge burst of light in the sky and then heard a huge explosion. Kulev said that after the explosion, he fell to the ground and the trees around him toppled over. The wind from the explosion blew Kulev's clothes and hunting equipment away. This testimony further details the sudden and devastating effects of the explosion. 6. Witnesses at Vanavera Station. Many people at the Vanavera trading station witnessed the explosion. According to witnesses, they saw a large fireball in the sky, followed by the sound of a powerful explosion. The wind created by the explosion shook the station building and knocked over many items. In addition, the heat wave felt after the explosion caused great fear in people. Testimonies from the Vanavara station show how far-reaching the effects of the explosion were. 7. Semyonova. What she remembers from her childhood. Anna Semyonova was a young child at the time and witnessed the explosion in the house where she lived with her family. Semyonova described seeing a large bright light in the sky and then hearing a powerful explosion. During the explosion, all the windows in their house shattered, and they felt a huge tremor in the house. In addition, the wave of wind that followed the explosion knocked over many items. Semyonova's testimony shows the powerful effects of the explosion, which were felt even at great distances. Conclusion. Eyewitness accounts provide valuable information about the severity and widespread effects of the Tunguska incident. Their accounts reveal the sudden and destructive nature of the explosion, its wide-ranging effects, and its profound impact on people. These testimonies play an important role in understanding the Tunguska incident and contribute to the understanding of the event alongside scientific theories. In the following parts of this documentary, we will try to solve the mystery of the Tunguska event by analyzing these testimonies in more detail in the light of modern research and technological developments. Modern research and its results. The Tunguska event has been an important natural phenomenon that has attracted the attention of the scientific community since the early 20th century. From the earliest investigations, many scientists and research teams organized expeditions to the region to understand the causes and effects of the explosion and developed various theories. With the use of modern technology and methods, more has been learned about the Tunguska event and more robust theories have been put forward. Here are the results of modern research. 1. Research by Leonid Kulik, 1927 and later. Leonid Kulik was a pioneer in the scientific study of the Tunguska event. Sent to the region by the Soviet government in 1927, Kulik conducted extensive research at the site of the explosion. On his first expedition, he examined the circular pattern of fallen trees and the abnormal structure of the soil near the center of the explosion. However, he did not find a large crater as he expected. This strengthened the theory that the explosion occurred in the atmosphere, not at ground level. 2. 1960s and 1970s. Aerial photographs and geological investigations. In the 1960s and 1970s, Soviet research teams organized several expeditions to the area. Aerial photographs and geological surveys documented the effects of the explosion in more detail. These investigations showed that there were no craters at the blast site, and that radiation levels were not above normal in certain areas of the soil. They also examined the direction and degree of damage to trees caused by the blast. 3. 1978. Giuseppe Longo and the Italian research team. Italian physicist Giuseppe Longo organized an expedition to the Tunguska region in 1978. Longo's team conducted a detailed biological and geological analysis of the blast site. They studied anomalous growth patterns in tree rings and determined the effects of shock waves caused by the explosion. These investigations provided more precise data on the magnitude and energy dissipation of the explosion. 4. 1990s. Chemical analyses and simulations. In the 1990s, the Tunguska event was re-examined using modern chemical analysis methods and computer simulations. Soil and plant samples from the blast site were subjected to micro-level chemical analysis. These analyses showed significant changes in the chemical composition of the area before and after the explosion. Computer simulations modeled the propagation of shock waves caused by the explosion of a large meteoroid or comet in the atmosphere. 5. 2000s and beyond. Satellite images and more advanced models. Since the beginning of the century, the Tunguska incident has been reassessed using satellite imagery and more advanced computer models. Satellite imagery provided detailed maps and topographic changes of the blast site. These data helped to obtain more precise information about the size and impact of the explosion. In addition, high-resolution models more accurately simulated the energy dissipation of the explosion and how shock waves behave in the atmosphere. 6. Comet and meteoroid simulations. Modern research supports that the Tunguska event was most likely caused by a comet or meteoroid collision. Simulations studying the behavior of comets and meteoroids in the atmosphere have provided detailed information about the energy and distribution of the explosion. These simulations show that the epicenter of the explosion occurred in the upper layers of the atmosphere, about 5 to 10 kilometers above the Earth's surface. 7. Radioactive isotope and microparticle analyses. Radioactive isotope and microparticle analyses of soil and plant samples from the blast site have provided more information about the nature of the explosion. These analyses have helped us understand the chemical composition of the explosion and how it reacted in the atmosphere. In particular, the effects of meteoroid or comet fragments on the chemical composition of the atmosphere have been studied. 8. Modern geological and biological research. Today, geological and biological research continues to understand the effects of the Tunguska event. We are studying how the vegetation and ecosystem in the region recovered after the explosion and assessing the long-term effects of the explosion. This research contributes to our understanding of the environmental and ecological impacts of major natural disasters. Conclusion. Modern research on the Tunguska event provides more precise information about the causes and effects of the explosion. In particular, the meteoroid and comet theories are supported by strong scientific evidence. Satellite imagery, chemical analyses, and computer simulations are more accurately modeling the energy release of the explosion and the behavior of the shock waves. These investigations have not only solved the mystery of the Tunguska event, but also revealed how vulnerable the Earth is to threats from space. In the following parts of this documentary, we will discuss the environmental and biological impacts of the explosion its socio-cultural consequences, and comparisons with similar events. Environmental and biological effects of explosion. The environmental and biological impacts of the Tunguska event were felt over a wide area due to the size and severity of the explosion. Post-incident research has examined how the flora and fauna in the region were affected and how the ecosystem recovered. 1. Destruction of forested area. The epicenter of the explosion was a densely forested area, and the blast affected an area of about 2,150 square kilometers. The blast wave uprooted around 80 million trees, which fell in a circular pattern from the center of the blast. The forest cover in the region was almost completely destroyed, and this had a profound impact on the ecosystem. 2. Soil and water pollution. The explosion caused chemical changes in the soil and water sources in the region. Investigations following the explosion found changes in the chemical composition of the soil and abnormally high levels of radiation in some areas. The chemical changes in water sources had a negative impact on plant and animal life in the region after the explosion. 3. Vegetation and regeneration. The eruption largely destroyed the vegetation in the area. However, over the years, the vegetation in the area slowly began to regenerate. First, fast-growing plant species and grasses began to cover the area. Later, the forest ecosystem gradually recovered, and tree species began to grow again. Modern research has studied the process of post-eruption vegetation regeneration and the ecological dynamics involved. 4. Impacts on animal populations. The explosion also deeply affected animal populations in the region. The sudden and violent explosion killed many animals. However, in the years after the eruption, animal populations slowly began to increase again. Predators and hunting pressure in the area decreased, which allowed the populations of some species to increase again. Sociocultural consequences. The sociocultural impacts of the Tunguska incident were felt across a wide spectrum due to the nature and magnitude of the explosion. The incident left deep traces on a wide range of people, from the local population to the scientific world. 1. Impacts on local people. The eruption deeply affected the local Evenk people. The Evenk were engaged in hunting and subsistence activities in the blast zone. After the explosion, the destruction of the forested area and the change in the ecosystem negatively affected the Evenk way of life and livelihoods. The sudden shock and devastation caused by the explosion remained a talking point among the locals for a long time. 2. Contribution to scientific research. The Tunguska event has been the subject of extensive research in the scientific world and has led to the development of many theories. Research into the nature and causes of the explosion has provided important insights into meteorites, comets, and atmospheric explosions. Furthermore, the event demonstrated the Earth's vulnerability to threats from outer space and prompted the need to assess the likelihood of such events occurring again. 3. Impact on popular culture. The Tunguska incident has also found a wide place in popular culture. From science fiction literature to cinema and television, the Tunguska incident has been referenced in many fields. Due to its mystery and dramatic nature, the incident has been the subject of many conspiracy theories and speculation. This has resulted in the Tunguska incident having a long-lasting impact on popular culture. 4. Education and scientific awareness. The Tunguska incident has been a frequently used example in educational materials and scientific awareness campaigns. It is recognized as an important case study for understanding the potential impacts of natural phenomena and threats from space. Educational institutions and scientific organizations use the Tunguska event to highlight the importance of natural disasters and space threats. Conclusion. The Tunguska event has left deep traces on a wide range of issues, from environmental and biological impacts to socio-cultural consequences. Modern research into the nature and causes of the explosion has contributed greatly to the understanding of the event. The impact on local communities and their contributions to the scientific community demonstrate that the Tunguska event had a long-lasting and far-reaching impact. In the following parts of this documentary, we will discuss comparisons of the explosion with other similar events and its impact on modern scientific research. Tunguska's scientific heritage. As one of the largest and most mysterious natural phenomena of the 20th century, the Tunguska event had a profound impact on the scientific world. The research conducted in the aftermath of the event has led to important developments and discoveries in various scientific disciplines. The scientific legacy of Tunguska is critical to understanding such events and preparing for similar events in the future. 1. Planetary defense and asteroid studies. The Tunguska event raised awareness about planetary defense. The possibility of asteroids and comets hitting the Earth and the potential impacts of such collisions were taken more seriously after Tunguska. The event led to the launch of efforts to track near-Earth objects, NEOs, and determine their potential hazards. NASA and other space agencies have established various programs to monitor objects at risk of impacting the Earth and to develop defense strategies against such threats. 2. Study of atmospheric explosions. The Tunguska event provided an important case study for the study and understanding of atmospheric explosions. It is understood that the explosion occurred in the atmosphere and released a large amount of energy. The effects of such events on the atmosphere and the Earth, such as the propagation of blast waves and the resulting heat waves, have been studied in more detail using modern simulations and modeling. 3. Shock waves and energy propagation. The Tunguska event provided a unique opportunity to study shock waves and energy dissipation. The shock waves generated during the explosion affected a large area, knocking down trees and causing widespread destruction. The behavior of these shock waves and their effects on the Earth's surface have been an important subject of research in modern physics and engineering studies. Simulations of such events have also been used to understand the effects of nuclear explosions. 4. Understanding environmental and ecological impacts. The Tunguska event has provided important data for understanding the environmental and ecological impacts of large explosions. Environmental scientists and ecologists have extensively studied how the ecosystem in the region was affected, how vegetation regenerated, and animal populations changed after the explosion. The long-term environmental impacts of such events have provided valuable insights into the resilience and recovery processes of ecosystems. 5. Radioactive isotope and chemical analyses. Radioactive isotope and chemical analyses of the blast zone have helped us understand the effects of the explosion on chemical compositions and reactions in the atmosphere. These analyses revealed anomalous isotope distributions and chemical composition changes in soil and plant samples from the region. Such data are important for understanding the interactions of meteoroids and comet fragments with the Earth's atmosphere. 6. Strengthening of comet and meteoroid theories. The Tunguska event contributed to the strengthening of comet and meteoroid theories and the understanding of the potential impact of these objects on Earth. Investigations following the event showed that the explosion was most likely the result of a meteoroid or comet fragment exploding in the atmosphere. These theories play an important role in modern astronomy and space science and provide a basis for tracking and studying objects that could potentially hit the Earth. 7. Similarities between the Tunguska event and nuclear explosion. The devastation caused by the Tunguska event is comparable to the effects of nuclear explosions. These similarities have provided important data for understanding and modeling the effects of nuclear explosions. Shock waves, energy dissipation, and atmospheric effects have provided valuable information that can be used to improve nuclear testing and safety measures. 8. Development of scientific methods. The Tunguska incident also provided an opportunity for the development and improvement of scientific research methods. The methods used during the investigation of the incident, such as aerial photography, geological and biological analysis, chemical and radioactive isotope analysis, have become standard in modern scientific research. Such methods are also used in the study and understanding of other natural phenomena. Conclusion: the Tunguska event had a profound and far-reaching impact on the scientific community and led to important developments in various scientific disciplines. Research on planetary defense, the study of atmospheric explosions, shock waves, and energy dissipation, environmental and ecological impacts, radioactive isotope and chemical analyses, comet and meteoroid theories, etc., have formed the scientific legacy of the Tunguska event. This legacy is critical to understanding similar events in the future and being prepared for such threats. In the following parts of this documentary, we will discuss comparisons of the Tunguska event with other similar events and its impact on today's scientific research. Similar natural disasters and comparisons. The Tunguska event is unique as an example of a massive explosion and destruction, but other similar natural disasters have occurred throughout history and in the modern era. In this section, we will compare the Tunguska event with other similar natural disasters and examine their common features and differences. 1. Chelyabinsk Incident, 2013. The 2013 meteor explosion in the Chelyabinsk region of Russia is a natural phenomenon similar to the Tunguska event. Explosion intensity and energy dissipation. The explosion intensity of the Chelyabinsk meteor was equivalent to 470,500 kilotons of TNT. The explosion intensity of the Tunguska event is estimated at 10 to 15 megatons of TNT. This means that the Tunguska explosion was about 20 to 30 times more powerful. Explosion in the atmosphere. In both events, meteorites exploded in the atmosphere, causing a massive release of energy and widespread destruction on Earth. The explosion of the Chelyabinsk meteor shattered the windows of thousands of buildings and injured around 1,500 people. The Tunguska event destroyed a large area of forest. Damage and injuries. There were no casualties in the Chelyabinsk incident, but many people were injured. In the Tunguska event, no direct injuries or fatalities were reported, as it occurred in an area farther away from human settlements. 2. Barringer Crater in Arizona. Barringer Crater in Arizona, USA, was formed by a meteorite impact about 50,000 years ago. Impact crater. Barringer Crater is about 1,200 meters in diameter and 170 meters deep. It shows a direct physical trace left by the impact on the Earth's surface. In the Tunguska event, there is no direct impact crater because the explosion took place in the atmosphere. Explosion intensity. The energy of the meteor impact that created Barringer Crater is estimated to be equivalent to about 10 megatons of TNT. This is similar to the explosion intensity of the Tunguska event. Ecological impacts. The formation of Barringer Crater dramatically affected the surrounding vegetation and animal life. The Tunguska event similarly affected a large area, destroying forests. Atmospheric and global impacts. The Krakatoa eruption released large amounts of volcanic ash and gases into the atmosphere, causing short-term changes in the global climate. After the eruption, temperatures around the world dropped and weather was affected. The Tunguska event did not cause global climate changes on this scale. Tsunami and direct damage. The Krakatoa eruption generated large tsunamis and killed around 36,000 people. No direct casualties were reported in the Tunguska event. 5. St. Helens volcanic eruption, 1980. The 1980 eruption of Mount St. Helens volcano in Washington state in the United States is one of the largest volcanic eruptions in recent history. Explosion intensity and energy dissipation. The St. Helens eruption released energy equivalent to about 24 megatons of TNT. This is comparable in magnitude to the explosion intensity of the Tunguska event. Ecological and environmental impacts. The explosion destroyed the surrounding forests and covered a large area with ash. Ecological impacts were similar to the Tunguska event, destroying vegetation over a large area and affecting animal populations. Destructive impacts and recovery. The St. Helens eruption affected the surrounding human settlements and caused extensive material damage. The ecological recovery process of the area after the eruption is similar to the ecosystem recovery process in the Tunguska event. Conclusion. The Tunguska event provides an important example for the study and understanding of large-scale natural disasters. Compared to similar natural phenomena, each event has its own unique characteristics and impacts. Events such as the Chelyabinsk event, the Barringer crater in Arizona, the Chicxulub crater, the Krakatoa volcanic eruption, and the Mount St. Helens volcanic eruption, when compared to the Tunguska event, show that such disasters can have a variety of impacts at both local and global levels. These comparisons allow scientists to better understand such events and be better prepared for similar disasters in the future.